After studying this module, you shall be able to know about the significance of operating systems, the history and types of operating systems, prerequisites and efficacy of operating systems. An operating system is a program which acts as an interface between the computer system users and the computer hardware components. It displays for a comprehensible setting in which a user may effortlessly develop and execute programs. Else, hardware knowledge would be compulsory for computer program. Operating systems obscures the complexity of hardware from apathetic users. The operating systems accomplishes resources and distributes them to specific programs and users. With the management of the operating systems, a programmer is cleared of difficult hardware deliberations. Operating systems afford services for processor management, memory management, file management, device management, and concurrency control. A running program does one very simple thing, that is, it executes instructions. Billions of times every second, the processor procures instructions from memory, decodes it and executes it. After it is finished with this instruction, the processor moves on to the next instruction and so on until the program finally concludes. There is a body of software in actual fact that is in control for making it easy to run programs, allowing programs to share memory, facilitating programs to interact with devices. That body of software is known as operating system or the OS, as it is in charge of making sure the system operates appropriately and proficiently in an easy to use manner. The primary requirement for operating systems ascends from the fact that the user needs to be delivered with services, and operating systems ought to be expedite the provisioning of those services. The operating systems makes memory accessible to an application when necessary. Additional characteristic for the usage of operating systems is that it is used as a predefined library for hardware-software interaction, and because of that, system programs apply to the installed operating systems since they cannot stretch hardware directly. In fact, operating systems itself is a program, but it has a main concern with application program. Operating systems uses the kernel, that is one program running at all times, mode of microprocessor, whereas other programs use the user mode. The dissimilarity between two is that all hardware instructions are effective in kernel mode, whereas some of them cannot be used in the user mode. Next is history of operating systems. In the beginning, the operating systems were not so much developed. Basically, it was just a set of libraries of ordinary used functions. It all started with computer hardware in around 1945. Computers were using vacuum tube technology, wherein the utilization of paper tapes, switches and punched cards were employed such that the program could be loaded manually. With the passage of time, elements for added hardwares were developed such as magnetic tape units, printers and card readers, and the development of software tools comprised of loaders, simple utility libraries and assemblers. Far along, the techniques of offline spooling and channel program methods were developed chronologically. Finally, the idea of multi-programming originated. Multi-programming means sharing of resources among more than one processor. The time-sharing systems came into being following the development in interactive computation during the period of 1970s. In these systems, multiple users have terminals and not computers, linked to a main computer and execute tasks in the main computer. Another computer system is the multiprocessor system, having multiple processors sharing memory and peripheral devices. With this configuration, they have better computing power and higher dependability. Multiprocessor systems are classified into two, as tightly coupled and loosely coupled. In the former one, each processor is assigned a specific duty, but processors work in close association, possibly sharing the memory. In the later one, each processor has its own memory and copy of the operating systems. In network systems, each process runs in its own machine. The operating systems can access to other machines. By this way, file sharing, messaging, etc. became imaginable. In networks, users are aware of the fact that they are working in a network and at what time information is being exchanged. The user ambiguously handles the transmission of information. Distributed systems are analogous to networks. However, in such systems, there is no requirement to exchange information unequivocally. It is handled by the operating systems itself whenever required. With persistent innovations, new architects and compatible operating systems are developed. Next is standards of an operating system. From the user perspective, the primary concern is always the convenience. It should be easy to use an application. The operating system must also progress uninterrupted, and when it fails, all applications running on the system fail as well. Because of this dependency, operating systems often attempt to provide a high grade of consistency. In system memory, data can be easily lost as devices such as DRAM store values in a volatile manner. When power goes away or the system crashes, any data in memory is lost. Thus, it is necessary that hardware and software should be capable of storing data persistently. Such storage is thus critical to any system as users cares about data. The software in the operating system that customarily manages the disk is called the file system. It is therefore responsible for storing any files the user creates in a trustworthy and proficient manner on the disks of the system. One objective of scheming and implementing an operating system is to deliver high performance. Another purpose is to restrain the overheads of the operating systems. These overheads arise in a number of forms such as extra time and extra space in memory or on the disk. Another objective is to provide protection among applications as well as between the operating systems and the applications. Next is types of operating systems. Operating systems are from the early computer generation. Operating systems keep progressing over the period of time. Following are some of the significant types of operating systems which are most frequently used. First is batch operating system. The users of batch operating system do not interact with the computer directly. Each user formulates job on an offline device like punch cards and submits it to the computer operator. To expedite processing, jobs with analogous requirements are batched together and run as a group. Thus, the programmer left their programs with the operator. The operator then categorizes programs into batches with comparable requirements. However, there are some problems with the batch systems, like there is a deficiency of communication between the user and the job. The central processing unit is frequently sluggish because the speeds of the mechanical input and output devices are slower than the central processing unit. In this type of operating system, it is difficult to provide the desired priority. Second is time sharing operating systems. Time sharing is a technique which enables several people situated at many terminals to use a specific computer system at the same time. Time sharing or multitasking is a logical extension of multiprogramming. Processors' time, which is shared between multiple users concurrently, is designed as time sharing. The main variance between multi-programmed batch systems and time-sharing systems is that in instance of multi-programmed batch systems, the purpose is to make the most of processor use, whereas in multi-sharing systems, objective is to reduce response time. Multiple jobs are performed by the central processing unit by switching between them, but the switch occurs frequently. Thus, the user can receive an immediate response. For example, in a transaction processing, processor accomplish each user program in a short burst or quantum of calculation. That is, if n users are existing, each one can get time quantum. When the user submits the command, this response time is in limited seconds at most. Operating systems use CPU scheduling and multiprogramming to provide each user with a lesser percentage of a time. Computer systems that were designed primarily as batch systems have been modified to time-sharing systems. Advantages of time-sharing operating systems are to provide advantage of quick response, avoiding duplication of software and reduction of CPU idle time, whereas the disadvantages of time-sharing operating systems are problems of reliability, problem of security and integrity of user programs and data, and of data communication. Third is distributed operating system. Distributed systems use multiple central processors to function multiple real-time application and multiple users. Data processing jobs are disseminated among the processors according to which one can execute each job most resourcefully. The processors connect with one another through various communication lines such as high-speed buses or telephone lines. These are referred as loosely coupled systems or distributed systems. Processors in a distributed system may be different in size and function. These processors are referred as sites, nodes and computers and so on. The various merits of this system are as the individual using this system can avail the resources that are present on another site while sitting on one site. Speed up the exchange of data with one another via electronic mail. If one site be unsuccessful in a distributed system, the remaining sites can potentially continue operating. Better service to the customers, reduction of the load on the host computer, and reduction of delays in data processing. Next is network operating system. This particular operating system goes on in a server and provides it with the facility of managing data, groups, users, security, networking functions and other applications. The primary determination of the network operating system is to permit shared file and printer access between multiple computers in a network. Characteristically, a local area network LAN and a private network or two other networks. The examples of this include Linux, Novel Network, Unix, Mac OS, Microsoft Windows Server 2003 and 2008, etc. The advantages of network operating systems are following. Centralized servers are highly stable. Security is server managed. Upgrades to novel technologies and hardware can be easily assimilated into the system. Remote access to servers is possible from different locations and types of systems. Whereas the disadvantages of network operating systems are high cost of buying and running a server, dependency on a central location for most operations. Regular maintenance and updates are necessary. Next type of operating system is real-time operating system. Real-time system is defined as a data processing system in which the real interval compulsory to process and respond to inputs is so small that it controls the environment. Real-time processing is always connected, whereas connected system need not to be real time. The time taken by the system to respond to an input and display of required updated information is termed as response time. So in this method, response time is very less as compared to the online processing. These operating systems are employed during the period of rigid time requirements when the processor is operated, or else the data flow and real-time systems can be employed as a control between a dedicated application. The system will be a failure if this specific system is not well defined and if there is no time constraint present. Also, this system is employed in science experiments, imaging procedures used in medicine, robots, control system employed in various industries, etc. There are two types of real-time operating systems: hard real-time systems and soft real-time systems. First, hard real-time systems. A hard real-time system promises that critical task completes on time. In hard real-time systems, secondary storage is partial or misplaced with data stored in ROM. In these systems, virtual memory is practically never found. Second is soft real-time systems. Soft real-time systems are less obstructive. Usually, other tasks are preceded by the critical real-time task and hence preserve the priority until it completes. Soft real-time systems have limited utility than hard real-time systems, and the various examples comprise of scientific projects such as an exploration in undersea and planetary rovers, multimedia, etc. Next is prominent operating systems. First, Unix. Unix is a computer operating system originally advanced in 1969 by a group of AT&T employees at Bell Labs, including Ken Thompson, Dennis Ritchie, and Douglas McCauley. Unix is one of the oldest operating systems in the computer world and is still extensively used today. However, it is not a very noticeable operating system, rather obscure in its operation and interface. It is preferably appropriate for the needs of large enterprise computing systems. It is also the most common operating system run by servers and other computers that form the bulk of the internet. Unix operating systems are commonly used in both servers and workstations. The Unix environment and the client-server program model were indispensable elements in the expansion of the internet and the restructuring of computing as centered in the network sphere than in individual computers. Unix was designed to be portable, multitasking, and multi-user in a time-sharing configuration. Unix systems are categorized by numerous concepts: the use of plain text for storing data, a classified file system, treating devices and certain types of inter-process communication (IPC) as files, and the use of a large number of small programs that can be strung together through a command line interpreter using pipes. As disparate to using a single monolithic program that includes all of the same functionality. These concepts are known as the Unix philosophy. Next is Linux. Linux shows and feels much like any other Unix system. Indeed, Unix compatibility has been a chief design aim of the Linux project. However, Linux is much newer than most of the Unix systems. Its expansion began in 1991 when a Finnish student, Linus Torvalds, wrote and christened Linux a trivial but self-contained kernel for the 80386 processor, the first true 32-bit processor in Intel's range of PC-compatible CPUs. Linux development revolved largely around the central processing system kernel, the core privileged executive that manages all system resources and that interacts directly with the computer hardware. The basic Linux system is a customary environment for applications and user programming, but it does not any standard resources of managing the available functionality as a whole. In its overall design, Linux resembles any other traditional non-microkernel Unix implementation. It is a multi-user, multitasking system with a full set of Unix-compatible tools. Linux file system observes to traditional Unix semantics, and the standard Unix networking model is implemented fully. Next is Windows. Windows XP implements the Win32 API. The Win32 API is the primary API for the family of Microsoft operating systems, that is Windows 95, 98, NT, 2000 and XP. A Windows XP application runs as a separate process, and each process may contain one or more threads. Windows XP uses the one-to-one mapping, where each user level thread maps to an associated kernel thread. However, Windows XP also provides support for a fiber library, which provides the functionality of the many-to-many model. By using the thread library, any thread belonging to a process can access the address space of the process. The general components of a thread include a thread ID exclusively ascertaining the thread, a register set demonstrating the status of the processor, a user stack employed when the thread is running in user mode, and a kernel stack employed when the thread is running in the kernel mode. A private storage area used by various runtime libraries and dynamic link libraries, that is DLLs. Next is Microsoft DOS. MSDOS was written for the Intel 8088 architecture, which has no mode bit and therefore no dual mode. A user program running skewed can obliterate the operating system by writing over it with data, and multiple programs are able to write to a device at the same time. Microsoft's first version of Windows, version 1, was based upon a GUI interface to the MS-DOS operating system. The example of the single tasking system is the MS-DOS, and because of its capability, it uses the simple technique wherein it does form a process but rather runs a program. It has a command interpreter that is invoked when the computer is started. Hence, this operating system performs the function of loading the memory and providing memory as much as possible by writing the program over itself. In operating system, the various levels of functionality and also the interfaces between them aren't separated well. For instance, application programs are able to access the basic I/O routines, to write directly to the display and disk drives. Such freedom leaves MS-DOS vulnerable to errant or malicious programs, causing entire system crashes when user programs fail. The MS-DOS operating system allows only 11 character file systems. We'll end this module with the summary. An operating system is a program that acts as an intermediate between a user of a computer and the computer hardware. The purpose of an operating system is to arrange for an environment in which a user can execute programs. Thus, the most important aim of the operating system is to make computer system easy for usage. Nowadays, operating systems make systems relatively easy to use, and virtually all operating systems you use today have been influenced by the developments. In the 1960s, the common arrangement of computing facility was a mainframe computer system. The mainframe computer system would be ordinarily housed in a computer center with a controlled environment, which was usually an air-conditioned area with a clean room-like facility. The users used to bring in a deck of punched cards which encoded the list of program instructions. It was in initial 1970s, Bell Laboratory scientists originated up with the now well-known operating systems, Unix. Similarly, when the microcomputers came into picture in the year 1980, a precursor to the present DOS was a system known as CPM. Most of the operating systems has a perception or a notion that when a program is executed, it can be regarded as a process. Clearly, with multiple applications active at the same time, there are many processes that are active. The operating system needs to manage all these processes. In a nutshell, we can say that the operating systems such as Mac, MS Windows, Unix, Windows NT, MS-DOS, OS/2 and Mac OS are the set of programs which play the ultimate role in controlling the computers.